Hi there and welcome to the screencast. Tonight I'm going to solve some of the problems you may expect to see on tomorrow's quiz on solving for the unknown angles and unknown sides of right triangles. So let's go. Alright, in the first problem here I'm asked to find the measure of angle theta, and the first thing I want to do when I'm asked to find an angle is to identify which sides are known relative to that angle. So relative to angle theta here, the side that is 16 is the hypotenuse, because it's always across from the right angle, which is angle C. And then the one that's 5 is the adjacent angle. And it's the adjacent because it forms a part of one side of the angle itself. Okay, so now I'm ready to write my trig equation. So let's see. For SOHCAHTOA, which one? Now I look at the first letters of hypotenuse and adjacent, and I see that hypotenuse starts with H and adjacent starts with A, and the trig function with A and H is cosine. So my equation then is going to be cosine of theta is equal to, it's going to be adjacent over hypotenuse, so that would be 5 over 16. Okay, as I think I told you in class today, and when we've been going over these problems, that when you're solving for an unknown angle, you're always going to use the inverse trig functions to solve for the angle, and that's always going to be the last step. That's how you get the angle measure out from inside the trig function. So I'm going to do inverse cosine of both sides of the equation, and that's going to leave me with the measure of angle theta, which I need to do on my calculator as, let's see if I can get this calculator so that you can see it. So I'm going to do inverse cosine, and then if I'm using a calculator, Casio calculator, I'm going to have to remember to add the parentheses. And 5 divided by 16, and that gives me 71.79 degrees, which I will round to 71.8 degrees. Alright, the next problem, I think I'm asked to find a side length. Okay, so I start this problem the same way. I look at the information I'm that I'm given and the side length that I'm trying to determine, and I decide relative to the angle I'm given which side is the adjacent, hypotenuse, and opposite. So for the 47-degree angle here, angle B, this would be the hypotenuse because it's across from the right angle. And then X would be my adjacent side because it forms a part of the angle that's 47 degrees. So it looks like I have another situation for cosine. I have adjacent and hypotenuse, which is the AH in Ka and SOHCAHTOA. So my equation is going to be cosine of 47 degrees is equal to adjacent over hypotenuse, so that would be x over 12. Alright, now I'm going to solve that equation by making a proportion by writing cosine of 47 over 1 degrees over 1, and then I'm going to cross multiply. And that's going to give me x equals 12 times cosine 47, which I'm going to do on my calculator. So I go to 12 times cosine 47, and that gives me 8.18 or 8.2, and I'm done. Okay, and then the last problem, I'm asked to solve an entire right triangle, meaning find all the side lengths and all the angle measures, and I'm given 2 side lengths as my only information. So when you're given 2 side lengths, I usually start by finding the third side length by using the Pythagorean theorem. So in this case, I'm given the one of the legs and the hypotenuse. So that's going to give me an equation that's going to look like a squared plus 6 squared is equal to 12 squared. And then if I solve that for a, I'm going to get a squared is equal to 144 minus 36 is 108. And then I need to take the square root of both sides of the equation, and that gives me an a value of square root of 108. And I'm going to do that on my calculator. If I can get out of the menu here. There we go. So I'm going to do square root of 108. That gives me 10.4. So that's the third side length. Now I'm going to use that information to find one of the acute angles by writing it and solving a trig equation. So here I can really choose whichever angle I want to solve for. It doesn't matter which one I choose as long as I set up the equation correctly. So let me choose angle B, and I'll use the 6 and 12 to solve for angle B. So relative to angle B, the side that's 6 would be the opposite side. This is directly across from that angle. And the side that's 12 is the hypotenuse. So the O and H in opposite and hypotenuse mean sine, because that's the so-and-so Katoa. So my equation then is sine of angle B is equal to 6 over 12, which I solve for B by taking the inverse, doing the inverse sine of both sides of the equation, and that gives me the measure of angle B as being equal to inverse sine of 6 over 12. So I'll do that on my calculator. Second sine 6 divided by 12, and that gives me a 30-degree angle. So the measure of angle B then is 30 degrees, and then now that I know the measure of angle B, I can easily find the measure of angle A by subtracting the 30 degrees and 90 from 180, and that's going to give me the measure of angle A, which is 180 minus 90 minus 30, which is 60 degrees. So now I've solved my triangle. My sides are 6, 12, and 10.4, and my angles are 90, 30, and 60. And tonight's secret sentence is, I really wish it would snow. Alright, I hope you found this helpful, and get a good night's sleep, and we will see you tomorrow. Cheers.